In this video we will go over example 2.6a on page 39. It shows how to draw the graphs in figure 2.6 on page 28. So we begin by loading a formula for our graph. We want figure 2.6a. It's to be plotted over 0, 20. Using 1024 points, which is what we're using. So there's the noisy signal. To graph the clean signal, we remove that noise term, and the clean signal is plotted in there. It's a bit hard to see, but it's there. Now, if we compute the RMS error, it's done by clicking Analysis, then Norm Difference, and clicking on the power norm of 2. And if we now compute, we get about 0.059 for the RMS error. Now to do denoising, we will transform the noisy signal. We'll do a Haar transform, 10 levels. Now to get a good view of where the noise is in there, we'll change the y interval to -4, 4. And the noise is coming out a lot in this these small random values there. The spikes are pretty much due to the underlying signal. Now to pick a threshold, as it says we did it by hand, we'll right-click on the graph, display cursor coordinates, and now from the readout we played around and found from -0.2 to 0.2 or so. Let's try it out. So we'll plot 0.2, unclick the auto fit, and now you can see the random values here are below that threshold, and then -0.2, they're above that threshold. So we can remove by using the following function. G1 of x, referring to graph 1, the Haar transform, absolute value of G1 of x greater than C, and we'll have C equal 0.2. So this will retain from G1 of x only those values whose absolute value is greater than this threshold C, which is 0.2. So now we click plot, and that is the purple graph, the thresholded transform. We now inverse transform that graph. We get this to compare with the noisy signal. We'll copy, to compare with the clean signal, we'll copy that graph, go back, paste it into the previous window, and now Analysis, Norm Difference. Again, graph 1 and graph 2, about 0.0587. Right? But now comparing graph 2 with the denoised signal, that is greatly reduced RMS error, about 5 times smaller. So there's an example of using the Haar wavelet transform to perform threshold denoising. That concludes this video. Thanks for watching.